Alright, welcome. Hope you're all having a good weekend. This question is from the topic of polynomials in Extension 2 Maths. However, it uses concepts from complex numbers and it's a very sort of standard question that you'll encounter quite often in exams. Hint, hint. Now, the question goes, show that cos 5 theta equals to 16 cos to the power of 5 theta minus cos to the cubed theta plus 5 cos theta. And hence, solve the equation 16x to the power of 5 minus 20x cubed plus 5x minus 1 equals to 0. And deduce the exact values of cos 5 theta over, 2 theta over 5 and cos 4 theta over 5. Now, the first step is a very, very standard procedure. It involves using the De Moivre's theorem. So if you know already how to do this, you may fast forward to the second part. Okay, to go through the first part, we first recognize that cos 5 theta is the real part of cos plus I sine theta to the power of 5. So what that means is that if we were able to use our binomial expansion to expand cos plus I sine theta, then we'll be able to identify cos 5 theta, which is the real part, with the real part of our expansion. So this does take a little while, so bear with me as I go through. So we might have cos theta plus I sine theta to the power of 5. Now, for the sake of saving paper and ink, we can write cos theta as c, so c equals to cos theta, and sine theta as s. So in order to go through that, we have the expansion, which is c to the power of 5 plus 5 choose 1, which is 5, of c to the power of 4 times s to the power of 1 times I. And we also have 5 choose 2, which is 5 times 4 divided by 2, which is 10. So 10 times c3 s2 I squared, which is negative 1, plus 5 choose 3, which is the same as 5 choose 2, 10 c2 s3 times negative I, because that was I cubed there, plus 5 c to the power of 1 s4 times I to the power of 4, which is just 1. And finally, we have plus sine to the power of 5 multiplied by I again. So notice how we've got this Pascal's triangle if you haven't already done binomial expansion. 1, 5, 10, 10, 5, 1, which is a pretty handy way of memorizing the binomial expansion, binomial coefficients of, something to the power of 5. Now, having got that, let's find all the real parts and equate that with cos 5 theta. So we have cos 5 theta, that's a cos 5 theta, equals to c5, because that's real. The second term here is not real. The third term is real, however, which we have minus 10c3 sine squared. That's not real. That is 5c(s4), and that is not real. So, but the problem here is we have things in terms of cos and in terms of sine. So if you go back to what we needed to prove, we needed to show that, cos 5 theta is all of that, and that's all in terms of cos theta. So we need to use the trig identity, that sine squared equals to 1 minus cos squared. Then we have c5 minus 10c3, 1 minus c squared, since sine squared is 1 minus cos squared. And over here we have 5c, 1 minus c squared, all squared, since it's to the power of 4. So expanding all of that, we have cos 5 minus 10c3 plus 10c5. Here, that's a long expansion. Now, I'm going to do this in one line, but if you want to check for yourself, then feel free to expand it in your own paper. So we have 5c, and then we have minus, now that part is minus 2c squared times 5c, giving us minus 10c cubed, and the last term will be plus 5c to the power of 5, since that's c to the power of 4 times another c. So yeah, and if we simplify that, we should have what we want to prove. Now, if you don't have what you want to prove, then chances are you might have made a mistake in the algebra. So, okay, I do not recommend fudging. Now, C5. We've got C5 here, C5 here, C5 here. That's 16 c to the power of 5. And over here, minus 10c cubed, minus another 10c cubed, minus 20c cubed. And over here, that's plus 5c. So voila, that's your showing part done. Now, we're asked to solve this polynomial equation, but this looks comparable to our identity, between cos phi theta and cos thetas proven previously. So what we can do is we can line them up and make the substitution x equals to cos theta and rewrite our polynomial. So I'm going to rewrite my polynomial down here, and it will look like 16 cos to the power of 5 theta minus 20 cos cubed theta plus 5 cos theta minus 1 equals to 0. Now, using a different color pen, you might notice that this part of our equation looks exactly like cos 5 theta, so we can change it into cos 5 theta. So in reality, what we're trying to solve is cos 5 theta equals to, well, minus 1 equals to 0, which in other words is cos 5 theta equals to 1. Now, in order to solve that, we have to make sure we know how to do our general solution to a trig equation. Or, if you were pretty good with the unit circle, you could just run it through in your head. So, in my case, I'm going to run it through my head on the left side and do the general solution on the right side, just to give you a bit of comparison. So on the left side, we've got, well, the first answer in the first quadrant would be 90 degrees, pi on 2 for 5 theta. So we say 5 theta equals to, wait, no, it's not 90, is it? Well, it will be 0. Now to get 1 again, we can get 2 pi. We can also get 4 pi. And 6 pi. And 8 pi. Leaving us with theta equals to 0, 2 pi over 5, 4 pi over 5, 6 pi over 5, and 8 pi over 5. Now if we go back to the question, where they're asking us to find the value of cos 2 pi over 5 and cos 4 pi over 5. And we notice that these are the angles we have. It means we're on the right track. Now, if you are not confident in doing this, you can use the general solution, in which case it will be 2n pi plus minus our principal solution, which is 0, where n is an integer. So now if we count through the different n values, since it's plus minus 0, it's very simple. So 5 theta again is the same thing. 0, 2 pi, 4 pi, 6 pi, and 8 pi, and so on. So going back to our list of solutions, I recommend us writing the solutions to the polynomial by listing them as cos of each of these angles. So what I mean is solutions of this polynomial, 16x5 minus 20x3 plus 5x minus 1. Since we made that substitution with x equals to cos theta, and we found the values of theta that satisfy this equation, then we know that x equals to cos 0, cos 2 pi over 5, cos 4 pi over 5, and cos 6 pi over 5, and lastly cos 8 pi over 5. These are all solutions of this polynomial. Now, because the polynomial is degree 5, this is perfectly acceptable, and if we actually went on to write 10 pi over 5, 12 pi over 5, and so on, these will be the same values as some of these solutions we have already, so there's no need to actually find any more solutions. Now, having a look at these solutions, notice how they, two of them are actually equal, which brings us to the next part. The question is, yes, we have solved the equation and found the solutions of this equation in terms of cos and radian angles, but the question here asks us to find the exact values of cos 2 pi over 5 and cos 4 pi over 5. So what do we do?